At this point, we spend a good amount of time writing out some basic SQL, and well, we've really not written SQL that kind of reflects a real world situation, to be totally honest with you. We've been working with single tables inside of single databases. So, for example, we've had this cities table over in pg-sql.com. That was the only table inside that database. And then, as you've gone through some different exercises, you've been working with a totally separate database that had a table of phones inside of it. Now, in any real world application, it is pretty darn rare to have just one table of data in a database. It is totally possible, and it probably exists somewhere out there, but you're probably not really going to see this in the wild too often. So, even though it would be kind of easy and straightforward for us to continue working with a single table of data to learn more about SQL, well, it just doesn't reflect reality. So, I kind of want to make things just a little bit more challenging for us. We're going to move ahead starting to work on a database for a kind of photo sharing application. We're going to work with multiple tables inside of a single database, and I'm going to tell you right now, this is going to be a little bit more challenging to understand. The reason that we're going to go to some more complicated stuff right away so quickly in this course is that, well, it just reflects reality. It reflects what you are going to actually be doing on a daily basis when you work with Postgres. So again, even though we could continue working with a single table, it just wouldn't be as great a use of time for us. Okay, so now we've got a good idea of how we're going to move forward. Let's have a discussion about how we might design a photo sharing application database and some of the different tables that might need to exist inside of it. In the last video, we said that we were going to work through the design of a database for a photo sharing application. And I showed you this diagram right here. So I'm saying that we should probably make a database that has 4 different tables inside of it: a list of users, a list of photos, a list of comments, and a list of likes. Just to be clear on what likes are right here, if you've ever used an application where you could maybe upvote some kind of post or like a photo, that's what this likes table is all about. It is for implementing some kind of liking feature inside of a photo sharing app. So your first question here might be, how did we come up with this design? How did I come up with these 4 different tables? Well, let's walk through a couple of tips that I have for you on building your own database designs. All right, so a couple quick notes here. What tables should we make for any particular application? The first thing I want to say is that a lot of times for any app you build, chances are it's going to have a lot of features inside of it that are common amongst many other web applications. There are many features out in the world, like let's say user authentication, some kind of liking system, some kind of commenting or discussion system that many different web applications implement. And to that end, there are tons and tons of resources online to give you suggestions on how to structure your database to implement these very common systems. Let's say, for example, that you are trying to build some kind of like system. You want to have the ability for your users to like images or maybe posts or something like that. If that was the case, your first resource, if you want to figure out some table design, would be a very simple Google search. For example, you could go over to Google and do a search for something like SQL schema, like, or maybe upvote system. And then immediately you're going to see tons and tons of resources online for how you might structure some kind of database to include some kind of upvoting or liking system. So anytime that you are building an application that has some feature inside of it that probably some other application in the world has, your number one resource is Google, and you're going to see a lot of discussion about how you might implement that. Now, of course, at some point in time, you might not be building some kind of very original application, and it might have some kind of feature inside of it that no one has ever built before. So what do you do at that point? Well, at that point in time, I would encourage you to maybe take a look at some mock-ups for your application. Maybe do you have some kind of mock-ups or preliminary design on what the user interface looks like? What is the purpose of your app? Our goal here is to try to identify the different kinds of resources that exist inside of your app. And as a first step, kind of a preliminary design, you might try to create a separate table for each of those different features or each of those different resources. Then for each of those different resources, you might try to find some kind of relationship or ownership between those different resources. Now, these 3 items here that I put in this diagram, I can lecture all day, but my words that I'm sharing right now don't really give you a lot of knowledge. They're not really effective. You really just have to see this in action. So let's do that right away. I'm going to take a look at 2 screenshots out of the Instagram mobile application, which is also a photo sharing app. And I'm going to show you the process that I might go through to build some kind of database design for something like Instagram. So in this first screenshot right here from the Instagram mobile application, and by the way, I'm just going to assume that you are passingly familiar with what Instagram is and what it's all about, we can see that this is a user profile page. The user in this case is Instagram. It turns out that the Instagram company has their own Instagram account. Who would have guessed, right? So this is a profile page for a very particular user who signed up to this application. This is the profile for them, and we can see information about this user. Right away, I can identify that this user has a username. In this case, it is simply Instagram. This user also has some kind of biography right here, something that is just a little quick bit of text that describes this person. I can also immediately identify that a user has the ability to follow other people and has the ability to be followed. That immediately starts to indicate that there's some kind of relationship between different users. Users can follow each other. So that implies that there's some kind of relationship there. Then at the bottom of this page, I can see that there is a list of photos. Because there is a list of photos right here, this kind of indicates that there is a resource or maybe a table of photos that are stored in some kind of database. The other thing I want to point out here is that these are photos that are tied or owned or were posted by this very particular user. So that indicates that a user somehow owns or has a direct relationship to a number of different photos that are stored inside the database. Okay, let's take a look at one other screenshot, and then we're going to take all this knowledge and condense it down to some kind of preliminary design. So this is a screenshot for a singular photo, or singular post, as it's called inside of Instagram. So from this screenshot, I can very easily identify that there is some kind of comments resource down here. So there's presumably somewhere in some database stored a list of comments. The comments that are posted here are posted by very particular users. That indicates that there is some kind of relationship between comments and users. And the comments that are listed here are comments that are specifically intended for this photo or this post. These comments are for this post and not some other random post that's stored inside the database. That indicates that not only is there some kind of relationship between these comments and users, but there might also be some kind of relationship between these comments and this post as well. And then finally, it appears that users can like a photo or like a post in this case. So once again, that would indicate that first off, there is some kind of list of likes or some kind of like resource, and that there's some kind of relationship between a user and a like and a photo. All right, so from these two screenshots, we were able to kind of discern different types of resources that might exist inside this app and the fact that there's some kind of relationship between them. Now, the last thing I want to do very quickly, because I know this is a long video, we've established that there are these 4 different resources in this application. We've also established that a user somehow creates and owns different photos. We've established that a user somehow creates and owns comments. And we've established that users somehow own and create likes. In addition, we've established that there's some kind of relationship between photos and likes, because you can like a photo, and that photos and comments are somehow also related, because you can add some comment to a photo. So we can see right away by just drawing these lines, and never mind what the direction of the lines really mean or anything like that, we can see right away that there's some kind of relationship between records in each of these tables, and that somehow they are expressing either just a plain relationship or some kind of ownership of sorts. Okay, so now that we've come up with some idea of how to approach the design of a database, let's take this one step further in the next video. We've come up with an initial design for our photo sharing application database, and in the last video we really established that there's some kind of relationship or link between records in these different tables. So in this video, we're going to start to discuss how we can somehow reflect a relationship between different records that are stored in our database. To help you understand what is going on here, I first want to show you just this screenshot once again. So in this screenshot, we saw that we are looking at a profile page for a very particular user. And it looks like this user, called Instagram, had posted some number of photos. So we would say that these are photos that are somehow related or owned by this very particular user. So inside of our database, we need to set up some kind of relationship. We need some data somewhere that says these different photos belong to this user. To model this in our database, we're going to first learn about 4 different kinds of relationships. There are 4 different kinds of ways of relating together different kinds of records. After we understand some terminology around these 4 different kinds of relationships, we'll then discuss how we actually implement each of these inside of our database. And then, of course, we'll go through some examples as well. Okay, so let's take a look at a diagram and really understand the relationship between a user and photos, and then how we might describe that in the world of SQL. Okay, so in this diagram, we've got a user called Instagram here on the left-hand side, and this user owns many different photos. This user is somehow tied to these photos. We would refer to this kind of relationship as a one-to-many relationship. This is the first kind of relationship that we're going to look at out of 4 different kinds. So this is relationship type number 1, a one-to-many relationship. We refer to this as a one-to-many relationship because one user has many photos that are tied to them. So besides calling this a one-to-many relationship, in practical language, like everyday language, as you're talking to another engineer, to refer to this relationship, rather than saying one-to-many, you might instead say a user has many photos. Anytime you see the words has many, that is a sign of a one-to-many relationship. Let's take a look at another kind of relationship that's really just this same one, just kind of the opposite. So if we look at this relationship from the perspective of a photo, then we might say that a bunch of different photos belong to one user, or a single photo has one user. We would refer to this as a many-to-one relationship. So many different photos belong to one single user. And I want you to notice right away that out of these first 2 relationships we've looked at, one-to-many and many-to-one, they're the exact opposite of each other. And it really just depends upon which perspective you are looking at this relationship from. So if you're looking at this from the perspective of a user, it is a one-to-many relationship. If you're looking at it from the perspective of a photo, it is a many-to-one. So anytime you see one-to-many or many-to-one, you can kind of flip that relationship on its head, and the opposite will still be true. Now, I know this initial idea might be a little bit confusing, so let's take a look at a couple more examples and really understand what is going on with a one-to-many and a many-to-one. All right, so back here, another screenshot very quickly. So on this page, remember, we had the ability for users to post comments to a single photo. Let's try to imagine how we might represent this relationship and how we might describe it with the terms one-to-many and many-to-one. Okay, quick diagram here. There we go. So in this case, we have a photo, and a photo can have many different comments tied to it. So notice that term I just used, a photo has many comments. That is a sign of a one-to-many relationship from the perspective of the photo. And again, we can flip this relationship on its head and consider it from the perspective of a comment. So many different comments belong to one photo, or we might say a comment has one photo. And again, we would refer to this as a many-to-one relationship. Let's take a look at a couple more examples very quickly. All right, so we've got boat and crew member, schools and students, companies and employees. These are all examples of one-to-many or many-to-one relationships. And again, it just depends upon the perspective that you're viewing the relationship from. We would say that a boat has many crew members, a school has many students enrolled, and a company has many employees. We could take a look at the opposite direction, and we would say that a crew member has one boat. A crew member in general is only stationed on one boat at a time, and it is unlikely that they're going to be shipped around to different boats. Likewise, a student in general just belongs to one school. Now, I'm sure you might know someone who attended 2 different schools at the same time, but we're just going to kind of generalize this for right now and say that a student has one school. They are only enrolled to one single school at a time. Likewise, I'm sure you might know someone who has multiple different jobs. Totally possible. Many people in the world have many jobs. They are employed by many different companies, but we can kind of generalize this for right now and say that an employee has one company. They are employed by a single company at a time. So from the left-hand side, going to the right, we would say it's a one-to-many, one-to-many, one-to-many. And then going from the right to the left, we would say that it's a many-to-one, many-to-one, many-to-one. Okay, so one-to-many and many-to-one are the first 2 kinds of relationships that we are going to inspect. And for each of these, the kind of telltale sign are the words has many and has one. Anytime you kind of want to refer to a relationship using the terms has many or has one, that's always a sign that you have a one-to-many or a many-to-one relationship. So at this point, we're really just at the stage of describing these different relationships and kind of thinking about real-world scenarios of each of them. But we are going to eventually have to understand how to implement these relationships in data as well. So in the next video, we're going to examine two other kinds of relationships very quickly, and then right after that, we're going to figure out how we can somehow relate different records inside of our database using a one-to-many or many-to-one kind of relationship. So quick pause, two other relationships in the next video. In this video, we're going to take a look at two other kinds of relationships. And these two other kinds do not exist in the database that we are about to work on and put together. I only want to mention all four kinds of relationships right away, just so you know that these all exist. So the other two important relationships you need to understand are the many-to-many and the one-to-one. We're going to take a look at a couple of examples on these, and then go through a quick quiz, and we will see examples of these kinds of relationships later on inside the course. Okay, so let's get to it. So these are all examples of one-to-one relationships. In a one-to-one relationship, there is exactly one record that has a relationship to exactly one other record. And the opposite is true as well. Now, when I describe that with words, it doesn't make a lot of sense. Let's just take a look at a couple of examples, and I think you'll get the idea of a one-to-one relationship rather quickly. So the first example we might consider is boats related to captains. A boat only has one captain at any given time, and likewise, a captain is only the captain of one boat at a time. Now, I'm sure in the world you can possibly imagine that maybe there's some captain who was the captain of two boats at the same time, but again, we can kind of generalize this and just assume in general that maybe one boat has one captain and one captain has one boat. Likewise, a company might have only one CEO at a given time, and a CEO might only be the CEO for one single company. Again, I'm sure you could think of exceptions to this. There are definitely companies out there that have multiple different CEOs, and maybe a given CEO works for many different companies, but whatever, we can just assume, just for the purposes of this discussion, that a company has one CEO and a CEO has one company. Now, this is a pretty good example right here, capitals and countries. As far as I'm aware, there are no capitals or cities in the world that serve as the capital for many different countries at the same time. So we would say that a capital has one country, and a country has one capital. Students and desks. So in general, a student will sit at one desk, and a desk will seat one student at a time. And then finally, a person and a driver's license or some kind of identifying card or identification papers. A person probably only has one driver's license at a time, and that driver's license is intended for one single person. If I have a driver's license, I can't give it to you and have it work for you. The driver's license has my name on it, so it's intended to be a driver's license just for me and nobody else. Okay, so that's some examples of one-to-one relationships. Now, just one other kind of relationship that we're going to consider, that is a many-to-many. Now, this is where it gets a little bit trickier, but I'm sure you can still kind of understand this for right now. And again, we will see a practical implementation of many-to-many later on in the course. So a couple examples here as well. We might say that there are many students at a school, and all these students probably go to a variety of different classes over the span of a day or a week or something like that. Likewise, each of those classes have many students inside them. So we would say that a student has many classes, and a class has many students. How about tasks and engineers? If you consider a task or something to be done at a large software engineering company, there might be multiple engineers who are assigned to one task or maybe one project. And at the same time, a single engineer might be assigned to multiple different tasks. So a task has many engineers working on it, and an engineer might be working on many different tasks. Sports games is another great example here. So there might be many different players who play in a single football match. And there are many matches, or there are matches that have many players playing in them. Movies is another great example. So there are many movies that have been created in the world. The majority of movies probably have multiple different actors or actresses starring in them. and a given actor or actress might star in many different movies. And then finally, conference calls. Now, this is a little bit trickier because in this case, we're kind of considering the case of like time, like a long duration of time. So maybe over the span of 1 week, there might be many conference calls that have many different employees on them. And over the span of 1 week, there might be an employee that is in many different conference calls. Now, again, I kind of stress that time is a factor in this relationship because if we consider maybe just at this moment in time, well, maybe at a single instant in time, an employee is only in one conference call at a time. So we might say that over the span of a week, an employee will be in many different conference calls. All right, so again, these are all examples of one-to-one relationships and many-to-many relationships. We are going to see practical examples of these relationships later on inside the course, but for the database that we're working on right now, we're just going to be concerned with one-to-many and many-to-one. So at this point, we have examples or kind of an idea of what these 4 different kinds of relationships are, but we have no idea how to actually reflect or store information tying these records together inside of our database. That's the part that we're missing. So let's take a look at another couple diagrams in the next video and understand how we actually set up a one-to-many or a many-to-one relationship. We've now identified these 4 different kinds of relationships. So now it's time for us to figure out how to actually reflect these in data. How do we actually set up some kind of relationship inside of a table? All right, so we're going to introduce 2 other pieces of terminology and understand how these 2 additional things are going to help us set up these different kinds of relationships. So these 2 new pieces of terminology are primary key and foreign key. Primary keys and foreign keys are additional columns that we're going to add to a lot of different tables inside of all the different databases we create. Every single table we ever make is going to have a primary key. Now, you might notice that up to this point in this course, we have not created any tables with a primary key. Moving forward, every table we make, we will be giving it a primary key. The goal of a primary key is to identify an individual row inside of a table. Every value inside of this column is going to be some kind of unique value in that column. So for example, the first row right here in a photos table might have an ID of 1. So this is this row's primary key, an ID of 1. There will never be any other row inside of this table with an ID of 1. So if I ever reach into the photos table and ask for the photo with an ID of 1, I will always 100% of the time get exactly that row right there. Even if we sort the values inside this table, and maybe that row ends up down here, if I ask for the row with ID 1, still, I'm going to always get exactly that row. So the goal of a primary key is to uniquely identify this row inside of a table. The ID is always unique, and it's never ever going to change. That's our first little piece of additional terminology. Now, to actually set up a relationship between 2 different records, this is the important part. We're going to use something called a foreign key. The goal of a foreign key is to somehow relate this record right here to some record in possibly another table or even the same table. So in this case, we have a table of photos and users. And you might recall just a little bit ago, we said that a user has many photos. So we need to somehow set up a relationship between these different photos and a user. To set up this relationship, we are going to give our photos table a foreign key column. We're going to call that column user_ID. And inside of this column, we're going to store the ID of the user that this particular photo, so this one right here, belongs to. So in this case, we would say that this row and the second row right after it belong to or are somehow owned by or are somehow related to the user with ID 4. So over here inside of our users table, we have a primary key column as well called ID. So we would look up the user with ID 4 over inside that table. There they are right there, and there they are right there. So we've now formed a relationship. We have somehow related these 2 photos right here to the user with ID 4 right here. That is how we are going to implement a a one-to-many and a many-to-one kind of relationship. Remember, those two are very similar in nature. It really just comes down to the perspective that we are viewing this from. So now we could write a query that might take a look at our photos table. We could take a look at all the user ID values inside there. We could say, give me all the photos with a user ID of 4. And that would give me all the different photos that are associated with this user right here. And that's the idea. So if we wanted to find all the photos that were associated with user ID 1, so maybe this user with username Monahan93, we would take a look through our photos table. We would look at the user ID column. We would find all the user IDs inside of here that were equal to 1. So in that case, or in this case, it's this row right here. And we would be able to say that this photo is associated with user 93. And then same thing with the last one right here. If we want to find all the photos associated with Pfeffer, I guess is how we would pronounce that. That user Pfeffer has an ID of 2. So we'd go into photos, take a look at the user ID column. Okay, in that case, here's the only photo associated with that user. And so we would say this photo belongs to user Pfeffer. All right, so that is the basics of setting up a one-to-many or a many-to-one kind of relationship. We're going to make sure that all of our tables always have a primary key column. In general, we're going to store numbers in there. The value inside there is always going to be 100% unique, and it's never going to change. Then to set up a relationship with a row inside of another table, we're going to add in a foreign key, and we're inside that column, we're going to say, here is the ID of the user associated with this photo. Now, the first time you see this entire setup, it gets a little bit confusing. So let's take a look at a couple more examples and really better define this whole setup and go through some examples as well and get a really good idea of how we set up and maintain these relationships. We've now taken a look at primary keys and foreign keys. So we are going to use this idea of a foreign key to set up all 4 kinds of those different relationships. Whenever we talk about a one-to-many, a many-to-one, a many-to-many, or a one-to-one, we are always going to somehow involve a foreign key column. That is how we set up relationships. Now, this idea of foreign keys is a little bit challenging, so let's take a look at another quick example from this kind of image setup or image sharing database. So let's try to walk through the foreign keys that we would start to set up if we wanted to express how comments are related to users and comments are related to photos. So remember, comments have one user and comments have one photo. If we consider that relationship from the opposite direction, we would say that a user has many comments and a photo has many comments. So to decide which table is going to get the foreign key columns here, here's what we're going to do. We're going to say that the many side of our relationship is always going to get the foreign key column. So in our case, for photos and comments, it is a one-to-many relationship. Comments are the many side. So the comments table is going to get a foreign key column pointing at the photo that each comment belongs to. In the case of users and comments, a user has many comments, or we might say that it is a one-to-many relationship from the perspective of the user. So the comments are the many side of the relationship. So the comments table is going to get a foreign key column, and all the values inside there are going to point back at the user who created that comment. All right, so here's what we might end up with. Inside of our database, we've got comments, photos, and users. Comments has two additional columns on it now. So it has 2 foreign key columns, user ID and photo ID. The user ID is going to record the ID of the user who created this comment, and the photo ID is going to record the ID of the photo that the comment was created on. So if we want to figure out all the information needed for this first comment right here, we would say that comments, we look up the user ID, it's 4. So the person who created this first comment is that user right there. And then we added the image, we added the comment to the photo with ID 3. So it is a comment that belongs to that image right there. We can then repeat that process for all the other rows inside of our comments table. So for the second comment, it was created by that user, because it has a 4 right there, and there's user ID 4. And it was added to the photo with ID 2. and we can just go down the list. How about we just skip right to the last one? This last comment was created by the user with ID 2, and it was a comment that was added to photo with ID 1. So that's it. Again, we are going to use these foreign key columns to set up all of our different kinds of relationships. Now, as you first start to look at this entire idea of foreign keys, it is really complicated. And you might say to yourself, Stephen, there's no way this is how it's actually done. Yes, this is how we set up relationships. This is the only way. So we do have to really understand how this stuff works. The first time you see it, it does look very confusing. But I've got great news for you. It is a very mechanical process. Setting up relationships is always going to be done the exact same way. So you really just have to learn it correctly one time, and then it's going to make sense forever. All right, so last thing I want to do very quickly is just put out some notes or comparison between primary keys and foreign keys. Primary keys, I think that you're probably going to understand really easily, really quickly. It is a key that is meant to somehow identify a row inside of a table. But foreign keys are just a little bit harder to keep in your mind. It's just a little bit harder to remember exactly what a foreign key does. So a primary key identifies one row in a table. It is always going to be 100% unique inside that table. So there will never be a duplicate value inside of a primary key column. The vast majority of the time, we're going to call the primary key column ID. That's it, simply ID. You will see a lot of other blog posts and tutorials and whatnot where they say, oh yeah, we'll set something like a country name, maybe, the name of a country, like that column, as the primary key. That's a really bad idea because as we saw a little bit ago, there might be multiple different cities in the world, for example, that have the exact same name. And because our primary keys always have to be unique, we cannot use the name of a city as an effective primary key column. So in general, we're going to usually call this thing ID, rather than trying to reuse some other existing column. The primary key is almost always going to be either an integer or a universally unique ID. A UUID is something that basically looks like this. It's just kind of like a random jumble looking characters. And then finally, for a given row, the primary key is never, ever, ever going to change. So if we ever create a user with ID 1, that is it. That is a user with ID 1. We're never going to reuse that ID, and it's never going to be assigned to any other user, never going to mess with it. And then foreign keys, very quickly, because I know this is going to turn into a long video. So a table only needs to have a foreign key column if records inside there belong to some other record inside of our database. Right now, as we've discussed our entire schema, users do not really belong to or don't serve on the has many side of any relationship. So our users table is probably not ever going to have a foreign key column, but just about everything else will. Foreign keys do not need to be unique. So many different rows inside of this foreign key column can be identical. And we even saw that in this diagram right here. Here's our foreign key column of user ID. And we see that two different comments belong to user with ID 4. So it is entirely okay to have duplicate IDs inside that foreign key column. Naming conventions for the foreign key is going to vary. As you go and work at some given company, they might have their own conventions, but what we are going to generally do inside this course is give it a name of whatever the resource is that we are pointing at or trying to reference underscore ID. And that's why you see over here, for comments, we've got user underscore ID because we are using that to point at a user, and photo underscore ID because we're using that to point at a photo. Now, it's always going to be a value that is exactly equal to the primary key of the row that we are trying to reference. So in other words, on this comment right here, the comment with ID 2, it was created by user with ID 4. That is always going to be, that value right there, always 100% equal to whatever the ID is of this row right here. And then finally, we will end up changing that value, unlike the primary key, if the relationship changes. So for example, if for some reason we could reassign who created a comment, it doesn't really make a lot of sense, but maybe you could somehow take over someone else's comment, so to speak. So maybe this last comment right here is currently saying that it was created by user with ID 2. Maybe for some reason we want to allow our system to allow some user to impersonate someone. I don't know. Who knows what it is? Basically, we can freely change this value right here and say, oh, you know what? Actually, this comment was created by user with ID 1 instead. Totally fine. Totally can do it. It changes the relationship. It means that this last comment was now created by this very different user, but it is 100% permissible. It is only the primary key column that we never want to change. All right, so I apologize for the long video, but that is pretty much it for an introduction on relationships and setting these things up using primary keys and foreign keys. So let's go through a very quick quiz, and then we're going to start to write out some actual SQL to see the implications of setting up these relationships and how we can actually use them to fetch data. Enough with the lecturing, let's try to figure out how to write some SQL that's going to actually generate some kind of relationship between two different tables. So in this video, we're going to generate a table of users to start. We're going to make sure that this table has an ID column, and we're going to figure out how to set up this column as a primary key column. When we set it up as a primary key column, that's going to make Postgres treat it in a very specific, very unique way. We're going to make sure this users table also has a username column as well. We'll make that a varchar 50 for right now. Okay, so let's get to it. I'm going to once again use pg-sql.com. Now, if you want to, you can reset your database. We've already created a table inside this database. You might remember the cities table. I don't really want to work with that cities table anymore. So I'm going to reset my database, which is going to wipe out all the tables inside of it. This is entirely optional. I'm just doing it to make sure I'm starting off with a totally clean slate. Then after doing that, I'm going to write out some SQL that's going to create this users table with an ID and a username column. So you might recall that to create a table, we will write out create table and then the name of the table. We'll then put in a set of parentheses, and then inside of here, we'll list out all the different rows, or all the different columns that we want this table to have. So we definitely want this thing to have an ID column. And then you'll notice in this diagram, I specified a type of integer, and it definitely looks like there are integers going inside there. But if we just specified a type of integer, then it would be up to you and I to somehow generate all these different IDs. And we would also have to write out some code, presumably, to make sure that we always generated some kind of unique ID. Rather than going through all that pain, we can rely on a little helper from Postgres itself. I'm going to put in a data type for the ID column of serial. The serial data type tells Postgres that we want it to generate the values in this column for us automatically. The serial keyword in particular means that whenever we start to insert values into users, we are not going to provide an ID at all. Instead, we are only going to provide a username. When we do so, Postgres is then going to jump in and generate an ID for us. The serial keyword means that it's going to start off by generating a value of 1 to start. As we then insert a second user, it will then take whatever the last ID that was generated for us, add 1 to it, and then assign it to this second record. When we put in the next user, we'll then get the next available integer, and then the next user, we get the next available integer. So as we insert additional users, the ID will be incremented by 1 every single time for us. After serial, we're then going to mark this column as primary key. This adds on some special performance benefits to looking up records inside the users table when we are trying to look up records using the ID. Then after the ID, we'll see that we also want these things to have a username, and it will be of type varchar 50. So remember, varchar 50 means that we cannot insert any strings longer than 50 characters here, and if we do, we're going to see an error. Okay, so that's pretty much it for our users table. Let's go ahead and run this. Looks like it was successful. Now I'm going to go ahead and try to insert a user into this table. So I'll do an insert into users, and then we're going to specify the one column that we want to try to provide here. Remember, the ID column is now going to be automatically generated for us, so we do not have to specify an ID when we insert a new user. The only thing we have to specify now is the username. So I'm going to add in 4 different users. I'll give them similar usernames to what you see right here. So I'm going to say users. I'm only going to put in the username, and we're going to stick in some values. And then remember, if we want to add in multiple records at the same time, we'll put in our set of parentheses, and then a single quoted string inside of here. For the first one, I'll put in Monahan 93. I'll put a comma on the other side. What was the next one called? Pfeffer, that old boy, old Pfeffer trying to sign up for an account. There we go. About, I don't know, what was the other one? Psy 93 Onus or something like that. And whatever the last one was, 99 Stroman. There we go. Make sure you've got the commas at the end of each of those parentheses, and the last one will have a semicolon instead. So let's now run this. So we've now added 4 users into our users table. So now let's try to query that users table, pull out all the records we just added, and all I want to do right now is verify and make sure that we actually got an ID inserted for each individual user. So I'm going to replace that with a select star from users. I'll run that, and sure enough, there we go. We've got an ID of 1234 for those 4 users that we just inserted. Each ID is 100% unique, and again, we do not intend to change these IDs manually at any point in time. ID number 1 is always for user Monahan93. 2 is always for Pfeffer, and so on. Okay, so that is how we generate a new table with a automatically provided ID. So let's take a brief pause. When we come back in the next video, we'll start to set up this photos table as well. We'll make sure that we also give it this user ID column, which is supposed to be a foreign key. Let's now create our photos table. Creating this table will generally look similar to our users, but we're going to also add in a foreign key column. So let's get to it. Back over here, I'm going to delete that query we had written out, and I will replace it with a create table photos. Inside of here, we want to have an ID column. Its type will be serial, and we want it to serve as a primary key for the table. Again, we're going to go into what primary key means a little bit later on inside the course. Then after that, we're going to add in our URL for the photo. I'll give it a varchar of how about 200. The URL right here is supposed to serve as a link to where this photo is stored. We're going to not really be working with any actual photos, so we'll put in some dummy data for this URL. Nonetheless, if it was going to serve a real URL, we might give it a length of 200 just to make sure it could store some really long URL. Then after that, we're going to add in our foreign key. We're going to call this column user ID, and it will contain a type of integer. We are not going to use that same serial that we used for the ID column over here on users, because if we mark user ID as serial, that means Postgres is going to try to assign a value to it for us automatically, and we don't want that. We want to be able to specify exactly what user provided a given photo. So we're going to create user ID, we're going to mark it as integer, and then we're going to add on one additional little piece of syntax when we create this column, and that additional little piece is what's going to turn this column into a foreign key column. So we're going to put in here user ID, it's of type integer, and then here's the magic part, we're going to write out references, then the name of the table that we're going to reference with this foreign key, its users, and then the column inside of that table that we want to reference in particular, which is ID. All right, so user ID, let's just walk through this very quickly, is going to contain integers that are going to reference some rows inside the users table. And the row that we are trying to reference is going to match up to the ID column. The user's ID right here is saying this column is going to try to reference something inside the users table, specifically the values inside of this ID column. That's what that last little piece says. So what does it really mean to mark a column as being a foreign key? Well, as you can see very quickly, it enforces some level of data consistency. Right now, that probably doesn't make a lot of sense. So let's just create this table, and then you'll start to see what marking this column as a foreign key really does for us. All right, so I'm going to run this query. Our table has been created. I'm going to insert into photos. I'm going to only provide a URL and a user ID, because once again, our ID for the photo will be automatically generated. We'll then provide some values. For this first photo, we'll just do one single photo, unlike users, where we put in 4 users at once. I'm going to put in some kind of fake URL here. So I'll put in, how about HTTP 1.jpg. Definitely not really a valid URL, but it doesn't matter. And then finally, as a second value, we're going to specify which user this photo is associated with. So how about for the first one, we do exactly what it says over here. I want my first image, my first photo, to be associated with the user with ID 4. So we're going to set up a relationship like that right there. So to set that up, I'll put in a 4, and that should be it. So I'll run that query, and that row has been inserted. Awesome. Let's now select all the different photos. Well, I guess the one photo that is in that table right now. So I'll do a select star from photos. I'll run that, and we've definitely got it in there. All right, so at this point, well, we've got a 4 there, but who cares, right? What does that really do for us? Well, there's two big things that we get by adding in this foreign key. First off, we can start to write a lot of interesting queries that allow us to fetch all the different photos that are associated with a given user. We also start to get a little bit of what we call data consistency, and that's a term that I used just a moment ago. Let's take a pause here. When we come back in the next video, we'll start to learn how we can write some queries to fetch all the photos that were created by a given user, and then we'll start to also figure out what it really means to have some consistency in our data. Let's add in a couple more photos into our photos table, and we'll take a look at some different interesting queries we can write to explore the association between photos and users. So to add in a couple more photos, I'm going to write out an insert into photos. I'll then list out the different columns that we are going to provide. So we're going to give a URL and a user ID for each one. We'll then list out some different values. So remember, each of these sets of parentheses that we're going to write represents a different row that we want to put into our photos table. So for the first one, I'm going to put in another little fake URL right here. I'll put in http://2.jpg. And then I'm going to associate this second photo with the user that has ID 1. I'll put in a comma at the very end, and then I'm going to copy paste this line down a couple of times. I'll then fix the indentation. I'm going to update the URLs for each of these to something that just looks a little bit unique. I'll put in maybe a 25, a 36, blah. Yep, that looks good. And then I'll change the user ID in a couple of places. So we'll say that maybe user with ID 1 has 3 photos. Then I'll give the user with ID 2 1 photo. I'll give the user with ID 3 1 photo as well. And the user with ID 4 can have 2 photos. I'll then make sure that I put a semicolon on that very last line. Okay, so let's run this to add in a couple more photos. And then after I do that, I'm going to once again retrieve all the different photos inside the photos table. So we'll do a select star from photos. So now we can see the list of all the different photos that are inside of our database. Each of these different photos is associated with a different user. Some users have multiple photos, such as user with ID 1. It looks like they have 3 photos tied to them. User with ID 4 has 2 photos, and 2 and 3 have 1 photo each. So now that we've got a lot of data inside of here, let's figure out how to write some different queries to somehow retrieve these photos in a meaningful way. Let's take a look at a diagram and understand what that really means. So at some point in time in our application, we might want to retrieve all the different photos that are created by a very specific user. This makes a lot of sense. Think back to that profile page in the Instagram application we were looking at just a little bit ago. We were looking at a profile page for the user Instagram, and on that profile page, we listed out all the photos that person had posted. So this query right here is something that we are very likely to want to write out at some point in time in our app. We might want to get all the photos created by a very particular user. So let's try to find all the photos that were created by user with ID 4 by writing out the query you see right there. Notice how there's nothing really special inside of here beyond some of the syntax we learned earlier on inside the course. It's just a select statement with a from and a where to filter out some of the rows we get back. Okay, let's try that out. We'll do a select star from photos, and we'll say where the user underscore ID is equal to 4. Now before I run that, I still have the results down here that are the list of all of our different photos. And remember, user with ID 4 has 2 photos associated with them. So when we run this query, I would expect to get back 2 rows, and both of them should have a user ID of 4. Okay, so I'm going to run that, and sure enough, there we go. We've got 2 separate rows. These are 2 photos that are both associated with that user. So now we could take this data right here, maybe send it to some kind of front-end application, and list all these different photos on the screen, and these would all be photos that are associated with this particular user. Okay, so let's take a look very quickly at one other query. Now, this other query that I want to look at is very complicated. I'm going to tell you right now. As an instructor, I'm not really supposed to tell you when stuff is challenging, but I just want to be really brutally honest with you. Understanding join statements in SQL is one of the most challenging, if not the most challenging thing in the world of SQL. So this is just going to be a very small little taste of a join statement. We don't really need to understand exactly what's going on for right now. Right now, I just want to take a very brief glance at it. I just want to run the query and take a look at some of the results we get back. All right, so we're going to write out back over here, select star from photos. We'll say join users on users.id equal to photos.user_id. And then maybe instead of the select star right there, let's instead only print out URL and username. Now I want you to take very quick notice here. These two columns I've listed out are columns that exist on two different tables. URL is a column that exists on the photos table. Username exists on the users table. So presumably this join statement right here is somehow combining together the definition of two different tables. So we'll talk more about what join means in just a moment, but for right now, let's just run the query. So I'll run that, and now we can see a total list of all the different photos and the username with each associated user. So this kind of query right here would be fantastic if we were trying to build out some kind of main feed page. Maybe some page inside of our application where we're going to list out many different photos and show some details about the user that had created each one. You might recall that the Instagram application, we even looked at a screen that looked vaguely like that. Some screen that had apparently a photo on it with the user who had posted it. So this kind of query right here would be fantastic for getting a lot of photos and some details about the associated user. All right, so that's just a little bit on join statements. Again, kind of complicated. So for right now, I just want to give you a very quick taste of it, and we'll come back to this idea of join statements in a little bit. Okay, so these are two queries that we're going to write out fairly often whenever we are working with associated data. Before we continue with join statements, however, I do want to have a quick discussion about what these foreign key columns are really doing for us in Postgres. We're going to go back to that term that I mentioned just a little bit ago, that idea of data consistency. So quick pause, and we'll cover that in just a moment. Let's take a look at a very quick exercise on creating and using foreign keys. So in this exercise, I've already created two separate tables for you. There's a table right here called boats. I add in 2 boats to it. And then there's a table being created right here called crew members. I then insert 3 people into that crew members table. Your job is to add in a new column to the crew members table definition. That's this thing right here. And the goal of this new column is to somehow relate the crew members and boats tables together. When you create this column, you need to give it a name of boat_ID. Then finally, after that, step 2, you're going to find to-do number 2 right here. Your goal is to write a query that's going to fetch all the crew members from the crew members table that are associated with the boat that has an ID of 1. So 2 separate things to do here. First, add in the column, and then write in a query down there. Now, one thing I want to mention very quickly. This exercise editor that you are using right now is not actually using Postgres behind the scenes. Instead, it is using a SQL environment that runs directly inside the browser. Just because of some very small differences between Postgres and this JavaScript-based SQL environment, there are a couple of keywords that are slightly different. Most notably, to set up a primary key with an auto-incrementing value inside of it, in Postgres we use the keyword serial. And we just saw that a moment ago. But inside this online JavaScript environment, we set up an equivalent column just a little bit differently. Instead of saying ID serial primary key, in this environment it is ID integer primary key auto increment. I put a note right here on this whole fact. So you do not need to change anything on this row right here. You can leave it as is. Just be aware that when we make use of Postgres, we're going to instead write out serial. So just a very small difference, and you really don't have to touch anything related to it in this exercise. All right, so go ahead and give this a shot. We'll go over a solution in just a moment. Let's take a look at a solution very quickly. The first thing we have to do is add in a new column to the crew members table definition. I'm going to scroll down a little bit and find where the crew members table is created right here. I'll then find the comment for to-do number 1. So right after that, on a line 22 or so, we're going to add in a new column. This is going to be a foreign key column. It's going to reference the ID column on the boats table. And we're going to call the foreign key column boat_ID. This is what is going to relate a crew member to a boat. So we're going to put in here boat_ID, integer, and then references boats ID, like so. So remember, the keyword references means that this entire column is going to reference some other column in another table. We then write out the name of the table and then the actual column inside there. Well, that is it for step number 1. Now we'll take care of step number 2. We now need to write out a query that is going to fetch all the crew members that are associated with a boat that has an ID of number 1. So we're going to put that query down here at the very bottom of the file. So down here, we will write out select star from crew_members, and then we want to find where the boat_ID property is equal to 1. So we'll say where boat ID equals 1. And that should be it. So let's go ahead and check our solution, see how we're doing. All right, looks great. We've got these 2 crew members who are assigned to boat ID 1. Well, I hope you had some success here. If you didn't, as usual, don't sweat it. So many locations in this course, you're going to be practicing the same ideas very frequently. Because at the end of the day, with SQL, we end up doing a lot of stuff many times over. So let's pause right here and move on to our next topic in just a moment. In this video, we're going to start to talk about something called data consistency. This term refers to the ability of our database to make sure that the information that we are inserting into it and working with actually makes sense, and that all these different references between tables actually line up in some way. Let me show you what I mean. Whenever we insert a photo into this photos table, there are 3 different possibilities that we need to consider. First, we might try to insert a photo that is tied to a user that actually exists. That would be like all the insertions we have done so far. We might try to insert a new photo. Let's do that right now. Just kind of imagine it. So here's some new photo, and we need to decide what user this photo is associated to. So in the first scenario, or in the first case I want to consider, we would add in an ID here that actually exists inside the users table. That would be the values 1, 2, 3, or 4. Let's say it's 1. So if we do that, we are creating a photo that references a user that actually exists. If we do that, everything works okay. Everything works as expected. We insert the photo, no problem whatsoever. We can then run some queries to fetch all the photos associated with that user or do whatever else we want to do. So let's now consider the next case, the case in which we insert a photo that refers to a user that does not exist. What would happen there? And hey, what should happen? First, let's make sure this scenario really makes sense. So I'm going to delete that last user I just added. And now we're going to imagine that we attempt to add in a new photo down here. So I'll give it an ID of 8. And then maybe in this scenario, we attempt to attach it to a user that does not exist. So maybe for whatever crazy reason, we accidentally put in a user ID right here of 345,000. Well, there's no user with that ID. So we now have a record that doesn't point at any existing user. So what would happen here? Well, if we really think about this, this is a scenario that kind of doesn't make a lot of sense in any world, shape, or form. So if we ever try to insert a record and have an ID inside of a form column that points to a record that does not exist, we're going to end up with an error. That's what's going to happen. Let's try to test out this scenario really quickly, and we can see very easily that if we try to associate a photo with a user that doesn't exist, we end up with a nasty error message. Okay, so back over here, very quickly I'm going to do a select star from users, just to remind you that we only have users with IDs 1 through 4. I'm then going to attempt to insert into photos, and I'm only going to put in a URL and a user ID, and then some values of whatever, just once again, some random URL, and I'm going to try to point to a user that definitely does not exist. So we do not have a user with an ID of 9999. Let's try to run this and see what happens. So sure enough, we get a nasty error. It says here that we are trying to insert some new record into the photos table, but we are not allowed to do so because it's going to violate a foreign key constraint. This term foreign key constraint means that Postgres wants to make sure that whenever we set up this foreign key, it tries to reference a record that actually exists inside of the user table. In this case, there is no match, so we end up with an error. Now, this is a very good feature to have. It makes sure that you are not going to accidentally insert data into your database that just doesn't make sense at all. Now, the last scenario I want to think about, we might have photos inside of our application that are not actually tied to any user whatsoever. Who knows, maybe we want to have some image of the day that pops up whenever a user first logs into our app, and maybe that photo is not intended to be really associated with any user whatsoever. So what would we do in that case? Well, if we want to insert some kind of photo that is not going to reference any user at all, then instead of putting a 999 right there, we will instead put in null, like so. The value null is very special in SQL and Postgres. It means there's no value here. It's just nothing. So we can now run this, and we are able to insert that record successfully. Now if we delete that and replace it with a select star from photos, we get all of our different photos, and for our very last photo down here, you'll notice that the user ID column has a value of null right there, which means there is no user associated with this photo. So those are the three scenarios. Let me fill in this last one right here. We're going to put in a value of null for the user ID. So those are the three scenarios we have to think about when we are inserting data when it comes to handling consistency. If we try to reference a remote row that actually exists, everything works. If we try to reference a remote row that doesn't exist, we get an error. And then if we want to insert a record that doesn't have any actual association, we'll just put in a null for the foreign key value. Okay, so that's just insertion. But we need to also think about what happens when we try to update a record or delete a record as well, as it relates to all this foreign key stuff. So let's take a look at some other scenarios in just a moment. We've now taken a look at how inserting records plays with foreign keys. So now we're going to take a look at the exact opposite operation. What happens when we try to delete some record that involves a foreign key? So here's the situation I want to take a look at. Right now, inside of our database, we've got that photos table and the users table. Inside of photos, there are three different photos, these right here, that are all associated with a user that has ID number 1. So here's the question. What would happen if we deleted the user with ID number 1? So if we just dropped away user Monahan. If that happened, we would then have some dangling keys right here, some dangling references. In other words, these photos are now trying to reference a user that does not exist and never will exist. Remember, our IDs are making use of that serial data type. Whenever we use that serial data type, no ID ever gets reused, even if a record with some given ID gets deleted. So when we delete the user with ID number 1, there will never ever be another user with ID number 1. And so these photos right here are never going to be referencing any user again. So we would have to add in some code inside of our database or our application to somehow detect that we've got some photos here that aren't referencing any user that exists. And that would be kind of annoying and not the best thing in the world. So when we make use of foreign keys, we can specify some options or exactly what we want to have happen whenever we try to delete a record that some other rows are dependent upon. In this case, we would say that these three photos are dependent upon that user with ID number 1. We have a couple of different options we can use. In this table, we're seeing the 5 different options or the 5 different things we can do whenever we try to delete that dependent record. By default, the option that gets used if we don't specify anything at all is onDeleteRestrict. That means that if we try to delete a user when a photo is still referencing it, we're going to end up getting an error message. And we can test this very easily. Back over here, I'm going to write out a statement to try to delete the user with ID number 1. So I'll say delete from users where ID equals 1. That would result in 3 dangling photos. If I try to run that, I then get a nice big error message. So this is a foreign key constraint around deletion that is preventing us from deleting that user. Let's take a look at some other options we have available, and then we'll try to play around with these. And by the way, I know that right now it's not clear where we would use these options. I'll show you where in just a moment. So again, the default behavior is onDeleteRestrict. There's another option called onDeleteNoAction that will also throw an error. There is technically a difference between what restrict and no action does. We'll discuss what that difference is later. It's a very small difference that has absolutely no impact at where we are right now. Some of the other things we can do is something called a cascade delete. So if we do an onDelete cascade, that means that whenever we delete a user, we are also going to delete all the photos that reference it as well. So in other words, if we delete the user with ID number 1, our database would go into the photos table, it would find all the different photos that are referencing the user with ID 1 and delete those photos as well. OnDelete Cascade is frequently a really good option if we want to try to delete a user and all the data associated with them. Some other options we have are set null. So in this case, if we delete a user, we're going to find all the photos associated with that user and set the user ID of them to null. So in that scenario, we can imagine we would delete user with ID 1, and then we would go to null, null, and null. So these photos will still exist, but there is a clear sign here that says there is no user associated with them. And then finally, we can use an onDelete set default. So we have not discussed this yet, but when we create a table, we can specify that a column should have a default value associated with it. So when you and I insert data into that table, if we do not provide a value for a column, there will be instead some kind of default value that gets used. If we do that, and we set this option right here, then if we ever delete the associated user, the user ID column of the photo will be assigned some kind of default value. We'll see an example of that later on as well. Okay, so that's what all these different options do. But now your inevitable question is, where do we set these options? Well, that's the big question. Let's take a big pause right here. When we come back next video, we're going to figure out how to set these options, and we'll do some testing with Cascade and Null. In the last lecture, you found a little bit of SQL that looks like this right here. Make sure you copy-paste that SQL somewhere safe. We're going to use that statement several times inside this video. Our ultimate goal is to try out some of these different onDelete constraints and really understand how they work through example. Now to set up one of these different constraints, we're going to first drop our photos table. When we use the term drop in a SQL environment, that essentially means delete. We're going to delete or drop the entire photos table and all the photos stored inside of it. We're then going to recreate it several different times and insert some data into it. And each time we recreate that table, we're going to set up one of those different constraints. So let's try this out right now. I'm going to first get started by deleting the photos table, or dropping it is how we'd refer to this, by writing out drop table photos. I'm going to run that, and I should see a result of drop complete. If I now try to retrieve anything from the photos table, say with a select star, I would end up with an error that says relation photos does not exist. That is because we just deleted that table. Okay, so let's now recreate the photos table and insert some data into it. And as we do so, we're going to set up one of those different onDelete constraints. So I'm going to paste in the SQL from the last lecture that you just saw. So make sure you've got the create table on here and the insertion right there as well. So now, to set up one of these onDelete constraints, we're going to pick one out. The first one you and I are going to take a look at is onDelete Cascade. And we're going to add that phrase right there, onDelete Cascade, right after one of the foreign key columns that we set up when we are making our table. So in this case, we want to set up an onDelete Cascade on the user ID foreign column. So right after that column definition, I'm going to write out onDelete Cascade. And that's it. That's how we set one of these onDelete constraints. We'll then run this entire statement, or really both these statements. There we go. So it looks like the create was successful, and we also inserted some data into that table. So now we can test out the onDelete Cascade. Now, just a quick reminder on what onDelete Cascade does for us. If we attempt to delete a user, say the user with ID number 1 right here, all of the related photos tied to that user, so that would be the photo with ID 2, 3, and 4, because they are all related to user with ID 1, they should all be deleted automatically whenever we delete that related user. Let's test that out. Back over here, I'm going to delete that user by doing a delete from users where ID equals 1. So we've taken a look at the delete from statement before. That should delete from the users table, specifically the record with an ID of 1. I'm going to run that, and we'll see that the delete was successful. Now, in theory, behind the scenes, Postgres has also deleted those related photos. Let's do a select star from photos and just verify, make sure that the related photos got deleted. So we'll do a select star from photos. I'm going to run that. And sure enough, we do not see any of the photos related to the user with ID 1. That's it. That is the onDelete cascade constraint. Now you're going to use this onDelete cascade very frequently anytime that you delete some kind of record that has a lot of dependent records on it. A really good example of this would be if you are managing some kind of forum. So think about a discussion forum. A discussion forum has many posts and many replies inside of a post. If you ever delete a post or like a main discussion thread, chances are you would want to also delete all of the replies inside of it as well. Same thing would go with, say, a blog post. And very similar in nature, a blog post might have many comments tied to it. And if you delete a blog post, chances are you don't want to hold all the related comments in your database because there's really no expectation that anyone's going to ever try to read those comments. So you will very frequently set up a onDelete cascade between something like a forum post or a blog post and comments related to it. All right, so now that we've taken a look at the onDelete cascade, let's take a brief pause and then take a look at onDelete set null in the next video. Let's take a look at the onDelete set null constraint next. So once again, I'm going to go back over here. I'm going to drop my table of photos. So it looks like the drop is complete. And then I'm going to recreate that table. So I see create table photos right here. And then once again, after our foreign key column definition, I will put in onDelete set null, like so. Now before we try to run this, remember, we have an insert statement right here that's trying to insert 3 photos that are all related to the user with ID number 1. If we were to run this right now, we would end up getting an error message. And the reason for that is that there is no user with an ID of number 1 anymore. We deleted that user just a moment ago in the last video. That user does not exist. So if we were to run this insertion statement, we would end up with an error saying, hey, sorry, but there's no user to relate these photos to. So just for this particular test, I'm going to delete those 3 lines right there. So for this test, we'll instead try to delete photos tied to our user with ID 4, and just make sure that the related references get set to null instead. Okay, so I'm going to run this. It looks like the create was successful. And so now we can kind of picture what's going on inside of our database. It'd be something like this. This is what we currently have. Now we're going to try to delete the user with ID 4. Because we are using that set null onDelete constraint, once we delete that user, all the related photos will have this value inside the user ID column set to null, like so. Let's try this out. I'm going to delete all the SQL we just wrote and replace it with delete from users where ID equals 4. I'm going to run that, and it looks like it was successful. So now we can once again take a look at all of our different photos. So select star from photos, run that, and we can see very easily that we now have 2 photos inside of here with a user ID of null. So where would we want to use this? Well, this might be very useful if a user were to create some kind of resource, and then if we decided to, for some reason, delete that user, and then eventually said, okay, well, we still want to show the underlying photo. Maybe, for example, in the Instagram application, we might need to delete some kind of problematic user or ban them or something like that. But the post that they created might be very meaningful, and so maybe we want to hold those posts around. So that might be a scenario where we want to hold the related records around, even if we delete some other record that these things depend upon. Okay, so that is the set null constraint. Now we're going to take a look at setting up a default value and using the set default constraint in the next video as well. At this point, we've taken a look at how to set up a database for a photo sharing application. We've only got users and photos right now. We've at least seen how to set up a relationship between these two tables using foreign keys. We've seen some examples of very simple queries, and we've also seen just a little bit on maintaining data consistency by using those deletion constraints. So we're now going to start to add in a little bit more complexity to our database. I want to add in this new table called comments right here, which is going to definitely have some kind of relation with users and with photos. We're then going to take a look at how to write some very common queries. Queries such as how to get all the different comments that were created by a given user, how to get a photo with all the related comments on it, and so on. So although we've seen some simple queries, those were very simple in nature when it came to the relational data. Our focus here is going to be how to write some more complicated stuff. All right, so to get started, we need to add in this new comments table. Here's the structure of our database right now. You'll notice I've changed this diagram a little bit. We'd refer to this as a schema diagram, and it shows you the structure of our database. So we've got our table of photos and our table of users. Photos has ID, URL, and user ID, and those are the respective types, and users right now just has an ID and a username. So we now need to think about how we're going to store some list of comments in our database as well. And when we do so, we have to relate them to individual photos and to users, because we need to know which comment is intended for which photo and who wrote any given comment. So without a doubt, our comments table is going to need an ID column, just so we can refer to any individual comment. We're then going to need two other columns at least to set up some kind of relationship with photos and users. So I think that this second column right here, maybe we will call it photo ID, and that will be a reference to the ID of the photo that this comment is for. And then very similarly, we can also have a user ID, and that will be a reference to the user who actually created the comment. And then finally, we need some actual text for the comment itself. So we'll call that simply contents. I'll make it of type maybe varchar 240, which means that this contents field right here, the actual text of the comment, can be up to 240 characters. Any longer than that, and we'll throw an error. So I think this is a pretty reasonable structure. All right, let's take a quick pause right here. Rather than writing out the create table statement for this right now, I would kind of like to just reset our database entirely between this video and the next one, so that you and I will have an absolutely identical structure of database and absolutely identical information inside of it as well. So quick pause, we're going to reset our database in the next video and recreate photos and users and create comments for the first time.